Okay, so there's this really powerful new feature in Claude Code that's got everybody talking. It's officially called Agent Teams, but you know what? The community came up with a way cooler name, Code Swarms. And we are gonna dive right in.
So let me ask you something. Have you ever been there? You give your AI coding partner a really beefy, complex task like, hey, refactor this entire legacy module. And somewhere along the way, it just kind of gets lost. It hits a wall and just gives up on you.
You know, there's actually a name for this phenomenon. The folks behind this call it the 60% failure mode. The AI gets, I don't know, about 2/3 of the way through the job, and then its context window, it's like its short-term memory, it just gets so cluttered and noisy that its performance completely tanks. You're left with no choice but to just scrap the whole session and start over. And man, is it frustrating.
So, how do we break through that 60% wall? Well, that's where a totally new way of thinking comes into play. Enter the code swarm.
So what is a code swarm? At its heart, it's basically a team of AI agents, all working together on the same problem. Instead of having one single AI trying to do everything one step at a time, you have a team lead who can delegate specific jobs to a bunch of specialized teammates, and they all work in parallel, talking to each other to get the job done right.
And this right here gets to the absolute core of why we even need swarms in the first place. The big insight is that these large language models, well, they actually get dumber the more stuff you cram into their context. It's not just about hitting a character limit, it's that too much noise makes it impossible for the model to focus on what actually matters for the task at hand.
Honestly, the best way to think about it is like a real human engineering team. I mean, you wouldn't pull your database expert into a meeting about CSS button styling, right? Of course not. You let specialists focus on what they do best. Swarms are just taking that exact same proven idea and applying it to AI agents. It just makes sense.
All right, so we get the why. Now let's get into the nitty-gritty how. Let's pop the hood and see how one of these AI teams is actually built and how it all works together. So the whole architecture really boils down to 4 key parts. First up, you've got the team lead. That's your main AI session, the one that spawns the team and acts as the project manager. Then you have the teammates, and this is the super important part. Each one is a full separate instance of Claude Code. They all coordinate their work using a shared task list so they know what needs to be done next, and they talk to each other directly using a mailbox system.
Look, I really want to stress this point. This new team-based model is a massive, massive leap forward from the older sub-agent feature that some of you might have played with before. It's a whole different ballgame.
Okay, let's break this down. First, let's talk communication. With the old sub-agents, it was a one-way street. They could only report their results back up to the main agent. That's it. But with agent teams, whoa! The teammates can message each other directly, they can actually collaborate, share what they've found, and even argue about the best way to move forward.
And that flows right into the second massive difference, coordination. The old sub-agent model had a huge bottleneck. The main agent had to micromanage everything. With agent teams, because they have that shared task list, they can coordinate among themselves. When one agent finishes a job, it just grabs the next available one. The whole thing is way more fluid and efficient.
So let's put it all together and see the big picture. You've got your sub-agents, which are great for quick hits, focused, simple tasks. They're cheaper on tokens, but the communication and coordination are pretty limited. Agent teams, on the other hand, are built for the big, messy, complex jobs, the stuff that requires real collaboration. The main trade-off, of course, is the token cost, since every single teammate is a full-powered AI. All right, this is all great in theory, but where does the rubber meet the road? When should you actually use one of these things? Let's look at the sweet spots, where these swarms really come alive.
You know, the main idea here is actually pretty simple, but it's super powerful. You want to use swarms when having multiple AIs exploring different paths at the same time gives you a real, concrete advantage.
Okay, let's take debugging. This is a perfect example. We've all had those really nasty, hard-to-find bugs. Instead of trying one theory, then another, you spin up 3 or 4 agents. You arm each one with a different hypothesis about the bug's cause. They all go off and investigate at the same time, share their findings, and debate. Until, bingo, they find the real root cause way faster.
And the cool thing is, it doesn't stop there at all. I mean, think about it. Parallel code reviews. You could have one agent looking for security holes while another one is checking for performance bottlenecks. Or what about building a new feature? You could have one agent on the front end, another on the back end, and a third writing the tests all at once. The possibilities are huge.
Now, this all sounds incredibly powerful, and believe me,
It is. But hold on a second. Just like any powerful tool, you've got to be smart about how and when you use it. And listen, this is a super important warning. It is so easy to get mesmerized watching all these agents flying around generating code like crazy, but you have to remember, activity is not the same thing as value, because the real danger here is that you can generate a ton of garbage code incredibly fast.
And that really brings us to the core philosophy of how to use this tool effectively. Look, most of your effort, like 75% of it, should be spent breaking down the problem and defining it clearly. The tool you choose, whether it's a single agent or a whole swarm of them, that's the easy part. That decision comes after you have a solid plan. Always let the problem guide the tooling, not the other way around.
And hey, since this is still pretty new and experimental, there are a few gotchas you gotta watch out for. First, those token costs can add up fast with every teammate you add. Sometimes, the lead agent gets a little confused and starts doing work itself instead of delegating. And for now, there are some technical limits, like you can't resume a session with teammates and you can't have teams within teams. Just tough to keep in mind.
So after all that, what's the big takeaway? What's the one thing you should remember? This quote from the source material just nails it. The real core skill for developers in this new world isn't about writing less code. It's about getting really, really good at breaking down complex problems into clear structures that an AI team can actually understand and execute on. The bottom line is this: the architecture for these kinds of coordinated, collaborative AI systems is not sci-fi anymore. It's here. It's real. And it points to a major shift in how we're all going to be building software. The real question is, what are you going to build with it?